Hello and welcome. This is Dr. Himayatullah Khan, and today I am going to discuss non-parametric tests. There are two types of tests basically: parametric tests and non-parametric tests. In my other video, I have discussed parametric test already, and in this video, I am going to explain what are the various types of non-parametric tests and when we use these parametric tests. So the two assumptions of normality and randomness, if they are not satisfied, then we will go for non-parametric tests. These parametric tests do not use any particular test. These are also called distribution-free tests. So there are basically four types of non-parametric tests. Number one is sign test, and then there is Mann-Whitney U-test, which is an alternative to independent sample t-test. Independent sample t-test is parametric test. Then Wilcoxon test. Wilcoxon test is the alternative for the paired sample t-test, where paired sample t-test is a parametric test. Kruskal-Wallis H-test, and this is used as an alternative for the one-way analysis of variance, which is a parametric test. But Kruskal-Wallis H-test is a non-parametric test. Now let me do all these tests one by one. So I will open my data. This is my data file, and I would like to start with the sign test. But let me show what the sign test is about. The sign test is perhaps the oldest of all the non-parametric procedures. It is based on the binomial distribution. So there are certain assumptions of this test, and the data are continuous. The distribution of these data is symmetric, and the measurement scale is at least interval. Excuse me. So let me go back to the data, and this time I would like to use the sign test. So analyze, and since I am doing non-parametric test, so I will press non-parametric test and then legacy dialogues, and under the legacy dialogues I'll press binomial. Basically the sign test is a binomial, and let us suppose I want to analyze this variable, which is gender, and it has two categories, and I want to know whether the proportion of males and females in this sample is the same or different. So I will give the proportion. Let us suppose I assume that the proportion of male to female is 50%. I mean 50% are males and 50% are females. You can you can also change this proportion as per your desire, as per your requirement, but I am using 50% proportion. So 0.5 is the proportion. Now by pressing OK, the SPSS has computed binomial test for me, which is a non-parametric test. So in this table you see that there are two groups. Group 1 is male and group 2 is female. The total number of males is 258 and that of females is 216. Total number of observations are 474. Now this is the observed proportion. This is based on the actual data, and the data shows that 54% of the sample are males and 46% belong to are females. And this is the test proportion. I basically assumed that the proportion of males and females is 50%. Now, looking at the p-value, which is 6%, my null hypothesis was that the proportion on male and female is the same. That is, there is no proportion. There is no difference between the proportion of male and female. The alternative hypothesis was that the two proportions are not equal. Level of significance is 5%. Test statistic is a sign test, which is a binomial test here. and the decision rule is that my p-value, which is 6%, that is greater than 5%, so I will fail to reject null hypothesis. So my conclusion is that the proportion of males and females in this sample is almost the same, and you can also guess from this 54% and 46%, and on the basis of this significance value, they are not much different from each other. This is how we use the sign test or the proportion test. It basically compares the proportion of different categorical variables. Now let me go to another test, and that test is called MWU test. And MWU test is an alternative for independent sample t-test. Independent sample t-test is a parametric test, whereas MWT test is MWU test is a non-parametric test. So how can I do that? Let me go to the data. Here is my data, and let me go to analyze, and then to non-parametric test, legacy dialog, and this time let me go to independent sample test. I want to analyze current salary, which is my test variable, and my grouping variable is, say, gender. I will send it here, and I will define. I have basically two groups, 1 and 2. My 1 stands for male and 2 stands for female. And by default, Mann-Whitney U test is checked. But you can also check Kolmogorov-Smirnov or any other, but I am interested in Mann-Whitney U test, which is an alternative for the independent sample t-test. So now let me press OK, and here is the result of Mann-Whitney test. So if you look at this table, the first table basically is giving us ranks. There are two categories in gender, male and female, and this is the number of males, this is the number of females, and this basically is give us test statistics. And Mann-Whitney U test statistic is equal to 9616.5. And let me look at the p-value of the Mann-Whitney U test, and it is 0.000. So my decision rule is that I will reject the null hypothesis. My null hypothesis is that the average current salary of or the median current salary of male and female are equal. There is no difference between the current salary of male and female. And my alternative hypothesis is the opposite of that, that the two means are not the same. Level of significance alpha is 5%. Test statistic is a Mann-Whitney U test. Decision rule is if the p-value is less than the 5%, then I will reject null hypothesis. Otherwise, I will fail to reject null hypothesis. Since my p-value or the significance value is less than 5%, so I will reject null hypothesis, and my conclusion is that the mean salary or the median salary here of the male respondent is not the same as the median salary of the females. So this is a non-parametric test. Hope you understood it. Now I will switch over the other test, and that is called Wilcoxon test. And Wilcoxon test is basically an alternative for the paired sample t-test. So let me show you how we can do that. Let us suppose these are my two variables. One is salary and one is salary beginning. And I want to use a non-parametric test for the comparison of the averages of these two variables. So let me redefine these two variables, so that it is easy for you to understand. So transform and recode into different variable. So my current salary is my input variable, and I would like to call after after. Uh, Say this is the salary of the respondents after training. So I call it after training. Change it and old and new values. Uh, sorry, sorry. Let me go back. I'll mm, okay. Change it and old and new values are the same. Cancel it. Okay, let me compute variable. And compute variable, my target variable is salary. So not here. I will write target variable, and this is a salary after training. So after T, and that should be equal to current salary. So I will press OK, and it has been created. This is salary after training, and this is exactly the same as salary. Now I also compute another variable for this, and compute. This time my target variable is salary before. Salary before training, and my target variable is this time beginning salary. I will press OK, and SPSS is computed for me another variable. So here you see that I computed two variable, and this one is exactly the same as salary beginning, and salary after is exactly the same as the current salary. So I will compare the average of the after salary and the average of the before salary. But let us suppose that the two assumptions of randomness and normality do not fulfill. So I'm using non-parametric test, and that is Wilcoxon test, which is a alternative for paired sample t-test. So analyze non-parametric test, and this time I will go to two related sample, and when I press this, Wilcoxon is already checked here. So I will compare the pairs of the two sample. One is a salary after, and the other one is a salary before. So I will now press OK, and here is Wilcoxon signed rank test. I should not be worried for this test. These are basically based on ranks. This is my test statistics, which is Wilcoxon test statistic, and its z value is minus 18.864, and the p value is 0.000. Now my null hypothesis is that there is no difference between the average or the median of salary after and salary before. Alternative hypothesis is that the two averages are not the same. Level of significance alpha is 5%. Test statistic is Wilcoxon test, and my decision rule is that if the observed p value is less than 5%, then I will reject null hypothesis. If the observed p value is greater than the 5%, then I will fail to reject null hypothesis. Now in this case, I see that the observed p value is 0.000, which is less than 5%. So I will reject null hypothesis, and my conclusion is that the median salary after the training and the median salary before training are not the same; they are different. So this is how we do Wilcoxon test. I hope you understood. The last test, non-parametric test in today's series, is the Kruskal-Wallis H test, and it is basically a non-parametric test which is used as an alternative for the one-way ANOVA parametric test, which is a parametric test. So let us see how can we do that. uh, Analyze non-parametric test, and this time I will use K independent sample t test. K independent sample t test. Now my variable of interest is, say, current salary, which I want to test, and my grouping variable is this time employment category. And employment category is basically a categorical variable which has more than two categories. In analysis of variance, we are comparing more than two groups. Analysis of variance is a parametric test. Kruskal-Wallis H test is a non-parametric test, which is an alternative for analysis of variance. And here we also have a categorical variable which has more than two categories. So now define range. So since I have three groups, 1, 2, 3, so the minimum is 1 and the maximum is 3. I will continue. Now I will press OK, and here is my Kruskal-Wallis test. Now if you look at this table, the employment category has three classes, that is clerical, custodial, managers, and the total number of respondents is 474. 363 belong to clerical category, 27 come from custodial, 84 comes from managers, and this test basically uses a chi-square. The chi-square test value here is 207.679 and its p-value is 0.000. So my null hypothesis was that the current salary of clerical staff, the current salary of custodial staff, and the current salary of the managerial staff is the same. There is no difference. My alternative hypothesis is that the average current salary of clerical and custodial and manager, they are not the same. There is difference. Level of significance alpha is 5%. Test statistic is Kruskal-Wallis H test, and the decision rule is that if the p-value is less than 5%, then we will reject null hypothesis. If the p-value is greater than 5%, then we will fail to reject null hypothesis. Now, particularly on the basis of our observed data here, the current salary and the employment category, the p-value is 0.000, which is less than 5%. So I will reject null hypothesis, and my conclusion would be that the average current salary of the clerical staff and the average current salary of custodial staff and the average current salary of the managerial staff, they are not the same. There is a lot of difference among these three categories. Thank you very much for being with me, and I hope you have understood. If you could not understand this, please you can reach me at my email khan.himayatullah@yahoo.com. Thank you.